Hey guys, another mechanical minute for you. Another quick video. These are packed full of information. Feel free to pause this at any time and read the screen. I'm going to paraphrase through it fast because there's a lot of information and these videos are quick. This one's about OBDII monitors and repair verification. Systems like the EVAP emissions and the SCR require a few extra steps to verify quality repair. For this mechanical minute, I chose the SCR system as an example. We all know that SCR stands for Select Catalyst Reduction, which can be confusing because there's also a piece called the SCR, which is basically a catalytic converter for the NOx sensor, for the NOx to be handled in. We got the dock. This piece is the first piece right out of the exhaust. It gets extremely hot due to increased RPM and fuel from the PCM during a regen command. Hot enough to burn particulate matter, turn it to ash. The DPF, diesel particulate filter, is the filter itself. It stores particulate matter and soot, and when it's burnt, turns to ash, still stays in there. The diesel exhaust fluid, the DEF, this is a subsystem. We all know it includes a tank, a pump, sensors, injector, and module. And its main job is to turn urea into ammonia as it decomposes in the exhaust rapidly, and that's where the NOx gets treated with that ammonia in the SCR at the end. The sensors needed throughout, there's NOx sensors that look at the NOx amount and report it back to the PCM. There's temp sensors throughout from the start to finish, multiples to look at different stages of the system and verify safe and effective operation during normal and regen events. And then the PM sensor, also sometimes referred to as a differential pressure sensor. Difference being that the PM sensor measures soot, where the pressure differential sensor looks at and estimates soot based on 2 points in the exhaust. Simplified operation, the SCR does two things basically. It converts the particulate matter, which is basically hydrocarbons, carbon monoxide, and soot and matter like water and metal, and gets rid of that. And then the further part down the system there, the SCR converts the NOx and gets that under control as well. So the OBDII monitors are done in two ways, the continuous and non-continuous monitors. Continuous are things that it needs that are essential to keep it running. It looks at things like misfires, spark ignition, cam and crank signals, and other sensors that have rationality ability and are required to make the engine run. Non-continuous monitors are things that aren't required that it looks at after the fact, like SCR, boost pressure, exhaust gas sensors, PM filters, EGR, VVT, etc. And they can require multiple trips, predetermined drive cycles that need to happen before a determination on a fault is even made. So the question becomes, is it really fixed? So let's say you got a vehicle in with a NOx sensor code and you change the sensors, which we should never do without diag to verify they're actually bad. But just for the sake of argument, you change the NOx sensors, clear the codes, test drove it, put it outside, you're all done, pat yourself on the back. A customer comes back in a week, same codes, right? Bad part. No, we didn't verify that it was actually fixed because that's a 3-trip system or whatever based on the unit. And it just didn't fit the drive cycles. They weren't done. You know, it took a week for it to do full drive cycles, which could include from a cold start up to temperature, certain highway speeds or RPMs for so long. Tank had to be between this level and that level, and then it had to cool all the way off, and that's one cycle. And then you got to do it again. It takes 3 of them to give a determination if the issue is still there. So just because the code didn't come back immediately does not guarantee it's a good fix. So basically, we're going to look at the OBDII monitors. They're usually in 3 statuses: complete, incomplete, or disabled, and they're exactly what they say. Complete means it's done, it's good, you can trust what it says. Incomplete means they're not done yet. You didn't meet the criteria to give you a determination. And disabled means they're turned off for whatever reason, anything from fuel level to temperature, whatever the case, it's disabled for now, and you'll have to wait. So basically, just look at the bigger picture, make sure we're in the right status, make sure we did a good repair, and obviously don't replace parts because there's a code. We don't ever want to do that. Hopefully this helps you out a little bit. And like I said, pause it where you need to read the screen. There's a lot of information packed in there, but I try to get it done as quick as I can. So there you have it. And again, if you know how something is supposed to work, you can better determine why it isn't working. This has been a mechanical minute. Thanks, guys.